So today we will discuss about the one topic in the optical communication is known as bending losses. So in previous class we will discuss about the different type of losses according to the optical fiber. First one is the attenuation losses. So then later you will discuss about the bending losses. So what is meaning of bending losses in the optical fiber? So according to the bending losses, when you look at the optical fiber, so this is the core region. Okay, na? This one is the core is normal. According to the bending losses, definitely there will be sudden changes in the core region. There will be sudden changes in the core and cladding regions. This referred to as a bending losses. Normally optical fiber look like a straight line, but according to the bending losses, the optical fiber will be change. One sudden changes in the curvature. There will be definitely sudden changes in the curvature that will be referred to as a bending losses. So generally the bending losses are classified into two types. The first one is micro bending. The first one is micro bending. The second one is macro bending. The second one is macro bending losses. Okay, now, so what is the basic difference between micro bending losses and macro bending losses? In micro bending losses, there will be small changes in the core and cladding region. There is very small. So these small changes will be when normally look at the optical fiber. When normally look at the optical fiber, these small changes are very difficult to identify, are very difficult to visible. Okay, now there is very small variations in the core and cladding region. According to the macro bending losses, definitely there will be huge changes in the core and cladding. There will be huge changes in the core and cladding region. So in this macro bending losses, when the light ray will be entering the optical communication, there will be reflected back. Okay, now once there are sudden changes, definitely the light will be escaping from the core region to cladding region, and the light is never back to the core region. The light is never back to the core region in the macro bending losses. So these are the general classifications of the bending losses. So according to the definitions are, you can go for what is the bending losses? The loss due to curvature and the loss caused by the abrupt change. There will be sudden changes in the radius of the curvature. So is referred to as the bending losses. Okay, now so bending losses mainly occur due to the mechanical failure. When you have designed the optical fiber, but the optical fiber look like a straight line, but according to the mechanic failure, definitely there will be some changes in the sudden changes in the core and cladding region. So you can observe this is the diagram representation of the bending losses. When the light ray will be enter into the core region, so it will be touches this point is called the core and cladding interference region, and the light is again is reflected back. So the light will be traveling in the fashion of the TIR. TIR means total internal reflection. When the light will be entering into the optical communication, it must satisfy the TIR fashion. So again the light will be reflected, and again the light will be reflected, and but there is a possibility of the light will be escaping from the core region to cladding region. Normally the light will be touches and will be again will be reflected back, but in these cases the light must be escaping from the core to cladding region. So this is the theory of the what you were explained in the previous, that is theory. Next one is the what is the multi-mode purpose. So you generally optical fiber classified into two types. Okay, step index fiber, gradient fiber. Again step index fiber classified into single mode and multi-mode. According to the multi-mode fiber, suppose you go to the multi-mode fiber, what will be happen? So the efficient n efficient is equal to n tends to n is the number of modes. N is indicate the number of modes. N efficient is equal to n tends to infinity of 1 minus alpha plus 2 by 2 alpha delta of 2a by r plus 3 by not to 3 by 2 into n2 k into r whole to the power of 2 by 3, where r is indicate the radius of the curvature. Similarly, the alpha is indicate the step index profile, sorry, graded indexed profile. Next one, delta is representation by the core cladding index differences. Next one, n2 is referred to as the refractive index of the cladding material, where k is nothing but the wave propagation constant, the value is 2 pi by lambda. Next, n tends to infinity is the total number of modes. N suffix infinity is nothing but the total number of modes in a straight fiber. Therefore, the final expression is n suffix infinity is equal to alpha by alpha plus 2 of n1 into k into a whole square into delta, where the n1 is representation as the refractive index of the core, refractive index of the core. Next one, classification of bending losses. Generally, the bending losses are classified into two types. First one is the micro bending losses. Second one is the macro bending losses. So what is definition of micro bending losses? So you go for the micro bending losses. General definition: there is a loss due to a small bends. There is a losses due to a small bending or distortion. So the small micro bendings are the not visible. When you look at the optical fiber, there is a difficult to identify the small bend. So what will be happen? The small bending happen due to the temperature will be changes due to the heavy temperature. The temperature related or crush related. These are the different types of the occur. The small bending losses will be appear in the micro bending losses. So how can will be reduce? How can we reduce the these losses? By installing process and testing process, definitely these losses can be reduced by installing. Okay, na, during the installation process and during the testing process, definitely these micro bending losses will be reduced or overcome. So whenever this is the diagrammatic representation of the micro bending losses. So when the light ray will went to the core region, definitely will be touches the core and cladding interference region, and will be again is reflected back. The light ray will be traveling look like in the TAR, total internal reflection fashion. So with there is a sudden very small changes, the light will be touches this boundary, again will be reflected back. So in this region there is a small variation. Definitely the light will be only in the core region only. Okay, now once the light will be go back to the cladding region, definitely reflect back to the core region. Okay, now so this is the representation of the micro bending laser. So you go for the multi-mode graded index profile. So what will be happen? The general formula f10 f of alpha comma m is equal to 1 plus pi of delta square by b by a whole to the power of 4 by e suffix f by e suffix j whole to the power of minus 2. Okay, na, where the delta is nothing but the index difference. What are the index? Means refractive index of the core and cladding. So next one, e suffix f, e suffix j are the Young's model of jacket and fiber. So the next one is the macro bending losses. The macro bending losses are the definitely will be definitely there will be large changes in the core and cladding region. Then compared to the micro bending and macro bending, definitely the macro bending is different from the micro bending. So the changes in the spectral attenuation caused by the micro bending is different to macro bending. So usually there are no peaks through, because in a micro bending no light coupled back to the core from the cladding has can happen in the case of the micro bendings. Okay, na. So when you are observed, okay, na. So when you are observed this is the representation of the macro bending loss. When the macro bending losses, when the light will be entering the core region, will be reflected back, and once there will be sudden changes, there will definitely the light will be escaping from the core to cladding region, and the light will be never return back to the core region. So you go for the bending losses for the multi-mode purpose. For the multi-modes purpose, so this is the general representation of the r suffix c is nothing but a critical radius that is equal to 3 into n1 square into delta by lambda by 4 pi n1 square minus n2 square all to the power of 3 by 2, where lambda is nothing but the wavelength, n1 is nothing but the refractive index of the core region, n2 is represent the refractive index of the cladding region.